Example 1. Comparing a quarter's weight and adult body temperature. Which of the following two data values is more extreme relative to the data set from which it came? The first one is the 99 degrees Fahrenheit temperature of an adult among 106 adults with a sample mean of 98.2 degrees Fahrenheit and sample standard deviation lowercase s, which is equal to 0.62 degrees Fahrenheit. Next, the 5.7790 grams weight of a quarter, which is among 40 quarters with a sample mean of 5.63930 grams and a sample standard deviation that's equal to 0.06194 grams. Okay, so the first thing we're going to do is we're going to take a look at the 99 degrees Fahrenheit body temperature and the 5.7790 grams weight of a quarter can be standardized by converting each of them to z-scores. Okay, so let's take a look at the first one. Now, it's very important to understand what are the values that's given. So if you take a look here, it says 99 degrees Fahrenheit body temperature. So that represents the data value x. So x is the 99 degrees Fahrenheit. Okay, then we have the mean. So the sample mean is 98.2 degrees Fahrenheit. And then the sample standard deviation is 0.2 degrees Fahrenheit. So now what we're going to do is we're going to use the following formula. So if you notice, here's the z-score. Okay, now remember the z-score is taking the data value. Well, the data value is always first, which is the 99 degrees Fahrenheit. And then we're going to subtract the sample mean. Well, the sample mean is 98.20 degrees Fahrenheit. And then we have divided by the sample standard deviation, which is 0.62 degrees Fahrenheit. So let me pull up the calculator here. Okay, and let's do this calculation just to make sure that we're on the same page here for the calculation. So we're going to take 99 and then we're going to subtract 98.20. Okay, and let me just minimize this just a little bit more. Okay, so we get 0.800000. Now we need to divide that by 0.62. And then it gives us 1.29032. Now remember that z-scores are always rounded to 2 decimal places. So the z-score for 99 degrees Fahrenheit is going to be 1.29 for the z-score. Okay, now let's take a look at the next one. So now we're looking at the 5.7790 grams. Now that's going to represent the data value. So remember that these numbers are representing the data value. That represents x. The sample mean is 5.63930. So remember, these are the sample means. Okay. And then we have our sample standard deviation, which is 0.06194. All right, so let's take a look here. We're going to use the formula again. So again, we know that we're going to take the data value, which is 5.7790 grams. And then we're going to subtract the sample mean, which is 5.63930 grams. And then we're going to divide it by the sample standard deviation. Okay, so let's do the calculation to verify our result. So we have 5.7790 minus 5.63930. And then once we do that, now we're going to subtract that result by the sample standard deviation, which is 0.06194. And then we get 2.2554084. .460. Now remember, we're rounding this to 2 decimal places. So that 5 tells us that we need to round up. So we end up getting a z-score of 2.26. All right, so now we need to take a look at the interpretation here. So the interpretation of the z-score is the following. Okay, we're going to say that the z-scores show that the 99 degrees Fahrenheit body temperature is 1.29 standard deviations above the mean, and 5.7790 grams weight of the quarter is 2.26 standard deviations above the mean. Now, because the weight of the quarter is farther above the mean, it is the more extreme value. So therefore, we would say that a weight of 5.7790 grams of a quarter is more extreme than a 99 degrees Fahrenheit body temperature.